Hey you guys, hope you all had a good spring break. Welcome back into the business.
We're excited to see you guys again and hope we can get you on track and learning some new skills. Chapter 11 is rather challenging, so we're hoping you're watching our videos. All right, guys, we're doing 11.2b, multiplying and dividing rational expressions. This one's going to mostly just be dividing, but for the bell work, to help you guys on one of the It's Learning quizzes, we're going to do this multiplication problem. If you look, these x plus 5 and the x plus 3, nothing can be canceled there, but there's this 2 and this 4 that can be reduced. So 2 can go into itself once, it can go into 4 twice. So up top, that's going to now just be x over x plus 3 times x plus 5 over 2, okay? And we're just going to multiply straight across. Instead of distributing, I'm going to go ahead and just attach them. This could be the look of your answer. If you went ahead and distributed, you could have x squared plus 5x over 2x plus 6. Both of those would be acceptable answers. Again, if you're doing It's Learning, if you get here and you don't see your answer, it's very possible that they went ahead and used the distributive property. So our first example, dividing rational expressions. Rational expressions can be divided just like fractions. So our big concept here is to flip and multiply. This is also referred to as multiply by the reciprocal. If you had myself or Mr. Newton for pre-algebra, this is the biggest concept that we talk to you guys always about, is multiply by the reciprocal. So the first example, the first thing that we're going to do is go ahead and flip this guy. So that's going to stay x squared minus 25 over 4x plus 28 becomes times by flipping it. Okay, so again on the side here, flip and multiply by reciprocal. That's your step one. Now we're going to factor or take out a GCF, and then we will multiply the remaining parts. So down here, x squared minus 25, remember that is the square root method, difference of squares. So we get an x plus 5 times an x minus 5. On the bottom, if you're looking at it, you should be seeing a GCF. You're pulling out the 4, and you're going to be left with an x plus 7. Times x minus 5 can stay x minus 5. Big X for the top, 1 times 14. That makes a plus 9. Okay, that's going to be 7 and 2. Divide by your a value. So x plus 7. X plus 2. Now you should be looking to cancel things. First thing that stood out to me was our x plus 7s and then also our x minus 5s. So x plus 7, gone and gone. X minus 5, x minus 5. And that should be it. So up top, x plus 5, x plus 2, all over just your 4. Any questions there? Okay, so before we go ahead and pause for you guys to do the practice problems, at the top, we're going to write on our homework, spring break. Spring break is now over, right? So if you forgot to remember, we're going to write keywords at the top of our notes somewhere within the video. This way, when you submit your homework, we can tell if you watched the video or not. So go ahead and pause it so you can do the practice problems. Okay, guys, so 2 practice problems here. Again, the first thing is to flip, so 4k plus 8 over 6k minus 10 times 9k minus 15 over k squared plus 6k plus 8. On the top, you should have a GCF of 4. Okay, so that's going to become 4 and a k plus 2. On the bottom, you have a GCF of a 2. So that's going to be 2, 3k minus 5. Up top here, you should have a GCF of a 3. 3k minus 5 is what you'd be left with over. And then we have a big X. So 1 times 8, that makes a plus 6. That's going to be a plus 4 and a plus 2. K and K. So K plus 4, K plus 2. Now you should be looking to reduce or cancel. I see I have my K plus 2's. I have my 3K minus 5's. Anything else? Miss May, anything else?
Ooh, the 4 and the 2.
Nice. So the 2 goes into itself once, and the 2 goes in here twice. So we're left at top with 2 times 3, which makes 6. On the bottom, just the K plus 4. That's going to be your answer there. Okay, for the second example, again, let's go ahead and flip this guy. So 8x squared minus 12x over x plus 7 times 1 over 4x squared minus 9. First part, you should be seeing a GCF, right? A 4 can go into 8 and 12, and you can also take out an x. So 4x, and then you'd be left with a 2x minus 3 over. Your x plus 7 will stay the same, times your 1 will stay the same. This one's a bit tricky, but it is the square root method, right? I could take the square root of 4, I could take the square root of 9. So that's going to become a 2x plus 3 and a 2x minus 3. Please make sure on the homework you're looking for these. These are probably some of the most challenging ones that students are not catching. From there, we're looking to simplify or reduce. I think just the 2x minus 3. 2x minus 3, that's it. So up top, we're left with our 4x. On bottom, x plus 7 and 2x plus 3. Miss May, anything to add or comment?
Can you cancel the x's?
Nope. Remember we talked about this being a pair, right? If there's adding or subtracting, they have to be exactly the same. So this 4x and this x plus 7 cannot be canceled. All right, we're going to flip to the back example. Looking at complex fractions. These are fractions inside of fractions. They can be simplified using division. So if you look right here, I'm going to go ahead and highlight it. That is our division bar, okay? In this example, we're going to write it out as a division problem to help you guys out. So to the side, I'm going to write it as a 1 over 2 minus x divided by x plus 3 over x squared minus 4. So all we are doing is instead of writing it with a fraction bar, we're going to write it with our division symbol. Our steps will be the same. The next step is to flip and multiply. So this guy is going to get flipped. Okay. Now we are going to start factoring or taking out the GCF. The 1 will stay a 1, but please, please, please pay attention to that guy. That is the one that is backwards, correct? So if you remember to make this become x minus 2, we take out a negative 1. Times. Up top here, again, square root method, right? So we have an x plus 2 and a x minus 2 all over x plus 3. If we did not remember to flip this, nothing would have canceled. On these, most of the time, something should be canceling at some point, okay? That's our tip for you guys. So the x minus 2's will be gone. And up top, we have x plus 2 over the negative 1 times the x plus 3. Miss May, what would you like to see some of your students do with that negative 1?
Distribute.
On the bottom or on the top? Bottom fine?
Bottom.
All right. So x plus 2 over negative x minus 3. Okay? So that would be an acceptable answer for us. Any questions? All right, so we're going to go ahead and have you guys look at this next practice problem, and we're going to pause the video so you can go ahead and give that a shot. All right, we're back. So we're going to go ahead and write it as a division problem. Again, if you've forgotten, remember this biggest looking fraction bar is our division symbol. So we're going to now flip it. 3q over q plus 4 times 2q plus 8 over 2q squared. All right, looking to simplify. We should factor first. Most of them cannot factor, but this can go ahead and be factored with a GCF. So here GCF is a 2. So we're going to write 3q over q plus 4 times 2q plus 4 over 2q squared. All right. First thing, that q plus 4 should have gone. This 2 and this 2 can be gone. And one last thing. This q can cancel and leave that with a q. So I did it in different colors so we can see what's left. We have a 3 up top and nothing else. On bottom, we have just that q. And that's going to be our answer. All right, guys, good luck on the homework. Let me and Miss May know if you have any questions. See ya.